is starting. Okay, this lesson is on scatter plots and best fit lines.
Yay!
Okay. So we're going to start with what a scatter plot is, do a little definition. So a scatter plot is a graph of bivariate, which I'll explain in a minute, data. I'm going to go ahead and squeeze data in that line. So bivariate means that you're going to have two variables. So it's like x and y, like we've done linear graphs before. You still have x and y. The difference between this and the linear graphs that we've done is that they're not going to be perfect straight lines. Okay, so these are not perfect lines. Okay, you might want to emphasize that. They are not perfect lines. You are not going to connect all the dots together and make a big, wavy, crazy looking thing. What we are going to see is some relationships. In real life, I guess do it, but in real life, when you collect information from a survey or you do a scientific study, not everything is going to fall into a perfect straight line for you. You're usually going to have a little bit of variation in situations. And so if we look at this first little graph, you can see how from the left to the right, most of the points are kind of going up. There's not really a line there, but it's kind of close to a line. As you go from left to right, the dots are going up. We call that positive correlation. Okay, positive correlation means there's a positive, co means with or together, relationship. So it means there's a relationship between whatever x and y is, and it's going up. And what we will do with this is we will make a best fit line that kind of goes through the middle that will represent the data. So go ahead and draw that little line kind of up through the middle, where it's not all going to have exactly the same line, but you come up with a best fit line. And what that does is that approximates the trend so that you could make some predictions. Are the predictions going to be exact? No, because not all the points are going to land on this line, but they'll be close. Okay, so this one, if you're going from left to right, you can see that the points are kind of, they're going down. As a general trend, as x gets bigger, y is going down. We call that negative correlation. And if you look at the best fit lines that I drew, this one has a positive slope. That one would have a negative slope. That's where they come up with the terminology. Sometimes when they do a study and they're trying to find a relationship between two things, they find out there really isn't any relationship at all. And so that's when the dots are just kind of all over the place. And we would call that no correlation. There's no trend showing up there at all. I can't really put a line in there to approximate anything. Actually, you can have a calculator do it, and it'll figure out if it's more this way than this way. But really, it's not going to fit.
How do you put that in a calculator?
We're going to learn. You're going to learn that probably next week while I'm gone. I'll have a video. So that's what I'm doing. Anyway. So you will learn how to do this on a calculator later, but we're going to do some of this by hand first. Or maybe we'll do that when I get back. I don't know. Okay, so we're going to talk about best fit lines. A best fit line is sometimes called a trend line. Okay? It goes through the middle of the data points. And you want it to stay close to as many points as possible. So as close to as, I should put bullets on this or something, bullets or dashes. As close to as many data points as possible. Okay? So it's sometimes called a trend line. Sometimes they will call it the line of best fit. Instead of a best fit line, it means the same thing. So it's going to go through the middle of your data points. It'll be as close to as many points as possible. It's going to show what the trend is in general. Okay? So we're going to take a look at a study that is kind of a biology study and use it to make some predictions and things. Okay? You guys got it?
Scatter plots and correlation.
Uh-huh.
Third one, what was that one?
No correlation. Okay. All right. So let's take a look at scatter plots. So someone somewhere who's either a zoologist or a biologist did a study where they were looking for a relationship between how big your brain was by weighing it in grams and how long as an average this species lives in years. So I would not want to do this. I would not want to cut open skulls and weigh brains, but somebody did. I know, exciting. And they only did, this is only showing 8 different animals. If you were doing this for real, you would study hundreds and hundreds and hundreds of animals. I also want to point out that these are all mammals. And so this would only work, you'd probably study mammals separately than you'd study fish, then reptiles. And then you might see if there's a relationship between the different things later. But you'd start with like one category. Okay, so this has already been set up for us. They went ahead and put the brain's weight on the x-axis and made that our independent variable, and then the lifespan, our y variable. So what they must be looking for is, if you have a bigger brain, do you live longer? You would think so, because you'd be smarter. You'd probably avoid things and take care of yourself. I don't know. But that's evidently what they're studying. So we're going to start just by doing the scatter plot. So the mouse's brain weighed 0.4 grams, and it lived 3.2 years. That's very small on this graph. If you look, each of these boxes would represent 50, because it goes 50, 100, 150, 200. So 0.4 is basically going to be at 0 for this graph. You're not going to really be able to go much past 4. So we're going to basically do 0. Going up the y-axis for the lifespan, it looks like it's going by 5s. 5, 10, 15, 20. So I'm going to be under the 5 over here on that 0 line. About right there.
Holy crap, this is going to be hard.
Okay? It is going to be a little bit time consuming, but you just have to look at it and estimate where it's going to go. It gets easier as the numbers get bigger. So for the fox, his brain was 50.4 grams and his lifespan was 9.8. So let's just, in our brains, round that off to 50 and 10. So basically, we're going to go over to 50, which is one box to the right. And then 9.8 would be basically 10. So I'm just going to put it basically at 50, 10. Okay? And then we get into some bigger animals. So the jaguar, we have 157 grams and about 22 years. So this would be 150 right here. I would probably just be a smidge past 150. And then we'll go just a little bit above 20 to do the 22. So it'd be about right there. And then the sheep is 175. So 175 would be between 150 and 200, halfway. And we'll go up to 20. And that's really close to this other dot. And it went down a little bit. That's okay. You're going to see a little bit of up and down when you do a scatter plot because it's not a perfect line. Are you all drawing this? Okay. So we're ready for the pig. The pig is 180. That's a little bit past 170, a little closer to 200. And then it lives for about 27 years, so that'll be between 25 and 30. So that's going to be about right there. And then the seal is 325, so that's between 300 and 350. So 325 is halfway, and it lives about 41 years, so just a little bit above the 40. It's about right there.
Hold on. I'm still on sheet.
Okay, I'm just going to keep going, and then we can pause at the end. So the donkey is 419 grams. So if this is 400, that's 450. It's going to be a little bit less than halfway between 400 and 450, and then it goes up to 40.
Well, it somewhat makes it kind of a straight line when you're finished.
Yeah, it's not a perfect straight line, but it's going to show you a definite trend. And then for the chimp, we've got 440, which is a little less than 450, and then go up to 50. So we do not go through and connect all these dots and make a wavy line graph.
Should we just do the
Isaac, turn
correlation?
around. But we are going to do a trend line.
So is that like the correlation?
So we can talk about correlation first. So looking at your example, would you call this positive correlation, negative correlation, or none?
Positive because it's going up.
Positive because it's going up. So let's write that up here. We definitely see a positive correlation. And what that means is as the brain gets bigger, they live longer. So as your independent variable gets bigger, the dependent is also growing. Okay? Now, I should have had you guys grab rulers, but just watch me and I'll show you what I'm going to do. You can kind of freehand this. In theory, you want to make it a straight line. Because this is going up, your line has to go up. I have had students make a line go this way. That does not show the trend in the data. You don't want a line going down if the data is going up. So when I say it goes through the middle, it's not through the middle, whatever direction you want. If you guys want to grab rulers really quick, that's fine. Or a protractor, something with a straight edge. What we're going to do is we're going to put a line that kind of goes up through the middle of the data. And we're going to try to hit some points. And we're going to try to have as few points on the left and the right side of the line as possible. So I'm going to hit this point, this point, this point, and this point if I can. I don't know if they'll line up. I think they kind of do. So I'm going to do that. And so I went through as many points as possible, and I've got 2 points that landed above and 2 points that landed below. That's a pretty good guesstimate. I've done this graph a million times. I do it every year. And so that's what you're trying for. So you want to have about as many points above the line as you do below. It does not actually have to hit any points if there's a big break in the middle. But if you can, hit several points that are kind of in the middle. And then you have, try to have as many above as below so that you're actually splitting it in half. So when I did it, I got 2 above, 2 below, and 4 points that look like they're more or less on the line. They're probably not perfectly on the line, but it's close. Okay, so that would be my best fit line or line of best fit. Now, we can do a lot of things with this line. Okay, what we are going to do is we are going to take 2 points that are on this line. They can either be points that came out of the table or points that the line just happens to go through. And we're going to make an equation for this line. Okay, using what we already know how to do.
Oh my God.
Okay, so I'm going to scoot this over. So let's pick some points that'll be relatively easy. What is this point going through over here? 440, 50. So I'm going to write that down over here. And so you know how I had to leave space on the right-hand side of your notebook? This is so that we can write this stuff out. So I'm going to go up a few lines just so I have room. So 440 and 50 is on this end of the line. And then we can use any other point that we wanted to that's on the line.
I would
147 and 40.
325 and 41.
325 and 41?
Yeah.
So 325 and 41. That's this point up here. I want to pick one of the points that's actually really close to my line. What's this one right here? 157, 22.4. So let's use that one, but I'm going to round off the decimal. Let's use 157 and 22. Because this line's not perfect, that decimal's not going to be super important. We can do that. So we're going to write an equation for this line, and then once we have that, we can use it to make predictions like we did on our last test where we, if I gave you a brain weight, you could tell me how long that animal's approximately going to live. If I give you their lifespan, you could tell me approximately how big their brain is.
So like giving us X and Y.
Yep. So basically, this is our x's, this is our y's. So when we're trying to find the equation of a line, hopefully you remember, we're going to find the slope first. So I'm just going to do top to bottom. I'm going to do 50 minus 22 and 440 minus 157. You could do it the other way, but make sure that you're subtracting the y's and the x's in the same order. I just didn't want to do it this way to get negatives. Okay, so 55 minus 22 is 28. 440 minus 157. I don't trust my brain, so I'm going to just make sure.
283.
Okay, is 283. So that's a weird fraction that doesn't reduce. In story problems, in real life problems like this, sometimes it's nice to go ahead and divide these on your calculator. 28 divided by 283, and go ahead and use a decimal. So when I put 28 divided by 283 in my calculator, I get about 0.0989. So since we know everything here is basically rounded, I'm going to round that off to the tenths. So I'm going to round that up to about 0.1 and use that as my slope. Okay? So let's think about what that would mean. Slope is rise over run. That would mean that my lifespan's going up 1/10 of a year for every gram of brain. It's kind of weird, but that's what it would mean. I know, because of the brain thing. I know. I got this out of a book, and I thought it was kind of interesting.
This is going to be fun.
Okay, and so then we're going to use our point slope formula. So which one point do you guys want to
It
use?
would
Do you care?
be y minus 50
Okay, we can do that. So we'll use the first point. So y minus 50
equals 0.1 x 440.
minus 440. Good.
Okay, this is
So then from here, it's just the same thing we're doing in the last unit. So 0.1x minus, this will be 44. And I still have y minus 50. So what do we do now?
you would add 50.
Add 50, and then add 50. And so y equals 0.1x plus 6. So let's kind of mark what all of this is. So this is,
Easy.
this would be 0.1 years per gram if we were going to label that rate of change. So basically this is saying you'd gain about 0.1 years per gram of brain weight. And then the 6 is a beginning number. If you look at this, it doesn't quite start at 0. It's up. And so we're adding an extra 6 years to each animal because it seems like this line doesn't start at 0. It starts up a little bit. So for whatever reason, we're adding like an extra 6 years more or less. Now my graph actually looks like it's a little bit below 5. It might actually be 4. This is not exact. When you do this by hand, it's not exact. And the thing that's really crazy that makes this hard to grade is we're all going to get slightly different numbers. Because if we had picked different points from over here that are not exactly, you might get a slightly different slope. You might get 0.2. You might get 0.15. You might get 0.08 or something.
Yeah.
And this number might be 5 or 4. It might be a little bit off. But we're just kind of learning how this works. Later on, I'll show you how the calculator has a method for trying to get it more precise. We can be a little more accurate, but this is just to give us kind of the idea of how this works. Yes. Yep. Okay, so that is what we're going to do on the scatter plot side. Now, before I pass out the handouts for the other side, where your practice pages, we are going to do something on the practice page that has to do with correlation. I did not, because I want this in the video. So page 63, I got to write this on here. What did I put on here? It was scatter plots. I started to write best fit lines, but... Okay, so this is the 20th. So the first handout that you're going to get looks like this. And you are going to fold that like a card with nothing inside. And then you're going to cut on the dashed lines to make 3 sections. I'm going to show you this, and then I'll give you the stuff to do it because I want to explain everything and then turn the video off. No, because you have to wait because Keegan's gone.
Keegan?
I'm sorry, not Keegan. Somebody's gone. It used to be Cameron or Keegan's seat. Okay, so you're going to make this into 3 flaps. See this? And so on the positive correlation, negative correlation, and no correlation, I'm going to give you pictures of scatter plots, and you're going to cut and paste the correct one in the correct place. That's the first part. And then on the inside, you're going to get a sheet that has a list of different things. And so you're going to tell me whether you think they would be a positive correlation, negative correlation, or zero. And then you can either cut these and paste them in the correct place, or you can write them in if you think that's easier. So let me do one of these with you. Just watch me, and then I'll give you everything you need. So education and income. So education would be your X, income would be your Y. So what you want to think about is if you had education this way. As you get more and more education, what do you think happens to the income? Would it go down or up? Okay, so we're thinking that this is probably more of an upward trend. So education and income, I would put under positive correlation. I would put education and income. Does that make sense?
Where's the full?
Okay, you don't have it yet. I just explained it. I'll explain it to you in a second.
We're doing this together? Or?
No.
Okay, good.
Okay, so I'm stopping the video.